there, this is Jacob Nash, and tomorrow is the 2023 AP Statistics exam. So, there's some things in AP Statistics that are easy to get mixed up with. And there's just some general things that people usually do wrong, specifically on the FRQs. Because if you know how AP works, they create their rubrics in a way that try to make it to where everyone loses points. Because they don't want to hand out the money easily, if you want to say. So I've created some flashcards here of some common things that people might mix up or get wrong. So let's get started. So how do you describe or compare distributions? I could say that almost definitely one of the FRQs on almost every exam will say that. It will show you some kind of, it might be a box plot, a histogram, or just a table, and it would say, describe this data or compare it. And you might think, if you don't know too much about the class, you might just think, oh, I'll just say something random. Well, they have specific things in the rubric that they want you to say. And you may or may not have heard of this acronym before, but it's SOX. It's a really good acronym for describing data. So you want to say the skew, outlier, center, spread. And in context, that's the other thing. They'll take off a point if you don't do that. So I won't try to be too long with this. And you can feel free to post any questions if you have them. But a skew, that's just saying, is it skewed to the left or right? And remember, for histograms, it's going to be, I would always draw a line, and if someone was like riding down that hill, which direction would they go? That tells you if it's skewed left or right. That's something people mix up too. I probably should have made one about that. So you just want to say that, if it's skewed or not. You want to say if there's outliers, and we're going to talk about how you know in a second. And then center, you're going to say what's the center of the data, and we'll talk about also whether you should use the mean or median, usually the median. And then spread, you're going to want to say the range and standard deviation, and we'll talk about how to find that too. But in context, what does that mean? That's not hard. It's not actually that hard. All that means is to say, use whatever information they give you. So if it's talking about like blood sugar levels or something, just say that. That's all you have to do. How you find a mean 5-number summary or standard deviation of a list. It doesn't have to just be a list. It could be a histogram too. If it's a histogram, then it's going to just take a long time, obviously, because you have to type in everything into the table, which is L1. But the thing about this class is that you should usually use the calculator only, but that doesn't mean that you don't want to know any of the formulas. Almost all of them are on the formula sheet anyways, so you don't have to memorize them, but you want to know how to use them because sometimes there's some dumb multiple choice question that the answer choices are only in that format. Otherwise, always use the calculator. And for any of those things, any calculation you might want to know about a distribution, you're going to want to type the data into L1 and then look at one var stats. If there happens to be a frequency involved or two L's, then type it into L2 and then do whatever. I'm not going to go into too much detail. How do you know if something is an outlier? It's just an outlier if it's outside of the IQR, which how you calculate that is Q3 minus Q1. You might say, how do you know Q3 or Q1? It says in one var stats. How do you calculate a test statistic? So here's another thing. We're going to talk about Z versus Z star and all those things. That's sometimes something someone could mix up. But a test statistic is always going to be this formula. And typically, if you see that, kind of looks like the Z-score formula because Z-score is a test statistic. It's a standardized score. That's not the only one that there is, though. But it's going to always be the sample divided by the population thing, if you want to say, and then divided by the standard deviation. Now, you have to know that the standard deviation occasionally is divided by the square root of n. Yeah, divided by the square root of n. And It's like that if you, we're going to say that in a second, of how you know if you have to divide by the square root of n. But so usually you would use this for means, but sometimes if you might want to do p hat divided by p, depending on what question you have. How do you know when to use z star or t star? Well, first of all, z star and t star are not a test statistic. Z is a test statistic, but z star and t star are called a critical value. And you would use z star if you know the standard deviation of the population. And so that would usually be for almost always for proportions. You will use that. If you remember zip, tem, I didn't come up with that, but z goes with p, t goes with means. Z goes with proportions, t goes with means. Now, so you're always going to use z star for p, but t star, you don't always necessarily use t star for means. Sometimes you use z star only if you know the population standard deviation. If you don't, you'll use t star, which is usually what you'll do. And I'll talk about how to calculate that too. What's the difference between z and z star? I kind of already said that, but z is a test statistic. Remember, you're going to use that formula that's basically the z-score. And then z star is a critical value. And to find z star, you can do it two ways, and you can do whichever one you think is easier. If you don't feel like looking on a graph and doing some dumb thing, then do the first one. You're going to want to do n norm. How do you get to that second vars? You're going to type, it's going to have like a thing in parentheses. The first thing you will type, you're going to use whatever confidence percent you're given, multiply or add it to half of 1 minus that. And then you'll do 0, 1. And the reason why you do 0, 1 is because you're assuming it's a normal, that's why it says normal distribution. If that seems too complicated, which kind of it is, then just look on their dumb graph that they have on the formula sheet, and you just look at the table. T star is easier to do, in my opinion. If you want to find T star, all you have to do is go on the table, and then you use the degrees of freedom. You have to minus or do that minus 1, whatever. So degrees of freedom, I mean, that's, I don't know why I said that. It's not degrees of freedom minus 1, it's the sample size minus 1. So if they tell you that a sample was drawn of 12 people, then you're going to use degrees of freedom of 11. If you happen to have 2 samples, if you're doing a 2-sample mean thing, then you take the smaller degrees of freedom. How do you calculate SE, or standard error? The only reason why you would have to do that if there's a question that specifically asks that, or if you had to do the confidence interval by hand. Usually, though, you don't have to do that, especially on the FRQs. This is only something you would do on a multiple choice. Well, luckily, all you have to do is look on the formula sheet. It tells you how to calculate the standard error of any possible thing. What do you say for interpreting a scatter plot? So just like we have SOX, some people use, I don't remember if they have a specific acronym. I don't really like that acronym. I personally just say this: plus or minus. That means, you say if it's positive or negative correlation. Strong or weak, you have to define X and Y. Don't forget that. You have to say X is this, Y is this. Then you have to say if it's linear. If it's not linear, like if it looks like it's exponential or something, then you might say it would be a good idea to linearize it or something. But you have to say it in context, just like the other thing. That means just use whatever values or information they give you. What is a confidence level? Confidence level is not the same thing as confidence interval. An interval is just saying, oh, we believe that it's in between these two values. But a confidence level is just saying how confident we are in the method that's used. You don't really have to do that often, but I just put that in there in case there was a question about that, because there has been before. If you were trying to interpret a confidence level, you would say that percent of the interval created should capture the true mean or proportion of whatever it is. How do you interpret a p-value? Now you might think, oh, that's what you do for rejecting or failing to reject a null. No, that's not the same thing. This is something that you don't have to do that often either, and you only do it if asked. If it says interpret the p-value, if that's like point C of FRP, then you would say there is a blank % chance of getting these results. And how do you get that percent? You just change the decimal you got of the p-value to 2%. That % chance of getting these results by random chance if the null hypothesis is true. Don't say null hypothesis. I put that in parentheses because you need to actually say what the null said. So the proportion equals 0.5 or something. Alright, now we're going to talk about our errors. What is a type 1 error? These are easy to mix up, but they're not that hard. It's just if you reject the null hypothesis when you shouldn't. Sometimes you'll be asked what's the consequence of this. So if it's like funding for some program, that's one of the most common ones. If it's like, if they did a type 1 error, then that would mean that they rejected it when they shouldn't. So that means they'll fund something that didn't need funding. Type 2 error is the opposite. It's if you failed to reject the null hypothesis when you should. So that would mean, oh, they said, no, we don't need funding, but actually you did, because the null is not true. But you always say things, remember when you're interpreting, you never accept the null, and you never reject the alternative. You fail to reject or you reject the null. Fail to reject doesn't mean you accept it. It just means, we couldn't necessarily say that it was wrong. What increases power? If you're asked to increase power, there will always be those stupid Roman numeral questions, but if you increase the sample size, if you increase alpha significance level, or if you decrease variability, that would increase power. How do you create a residual? A residual is, remember, it's just saying how off was our predicted line from the actual thing. By a certain point, you would say the actual y divided by the predicted y. You might have to do that as calculation. Not necessarily from a graph, but from information they give you. So I just remember hat last. And hat is always the predicted. So if you remember your algebra class, there was never a hat back then because they always do the actual. But since this is statistics, we use y hat because it's predicted. What symbols are for samples and populations? It's really important that you use the right symbol. Sometimes it's easy to mix these up, but if you use the wrong symbol, your AP reader might just be dumb and not give you the point. So here's what it is. For proportions, p hat is for the sample and p normal is just for the population. For means, use x bar for sample, use mu for population. For standard deviation, use s for sample and use sigma for population. Sample standard deviation isn't something that you use that much, so you might be like, I don't usually see s. Well, sometimes you might have to use that, but it's not that often. How do you interpret residual plots? It's not that hard to interpret one, but if there's a pattern, that's bad. Sometimes this is confusing, but if there's a pattern in the residual plot, like it looks like it's a wave or it looks like whatever, that would mean that it's actually not a linear scatter plot. Because remember, a residual is kind of just like the scatter plot turned flat. And if it's a pattern that's like, oh, dang it, that means it actually wasn't linear. So you would need to linearize it. So I don't have enough time to go in depth of this. I do have a video about it, but if, let's say you're like, oh, that looks like a square root function. Well, whatever thing is messing up, then you might want to square it. Or just do the opposite thing of what's wrong with it, and it will make it linear. If there's no pattern, that means it's good. If it's like random all over the place. What are the different kinds of sampling? Sometimes they might ask you that. Simple random sample is probably the most common. That's if you used a number generator or names out of a hat. Systematic is like maybe you're using a computer or every nth person. So that means like every 50th person, they're in the sample. Cluster and stratified, though, those are the things that people mix up the most. Cluster is if it's based on location, so we're going to sample these people based on where they are. Stratified is based on characteristic. We're going to sample men or women. So that it's not that complicated of a difference. But I also have a video about that if you want more depth. All right, how do you read printout data? Sometimes people call it something else. I can't remember what it is. But that's just if you have that dumb thing, a table that looks like gibberish. It has a lot of information, but on here I show what things that you would use. So the top row is pretty much useless. The only thing that you would want to use is conf, constant conf. That's the A, so that means that's the y-intercept. And then the predictor, and that makes sense, constant, that kind of makes sense. Predictor, that row you would want all those things you can use. Usually you only use the things that are on conf, though. I'm just saying, like, that most commonly those are only things you would have a question about. If it said use this printout data to make an equation, well, that predictor is your slope, constant is your y-intercept. But if it said find the standard error, well, that's the SE conf. If you wanted to find T star, that's what that tells you, and then P value. But you don't usually have to do that. Then down here, S is just the standard deviation of residual. You don't really have to do that often. But if they told you that, and then R squared is just R squared, coefficient of determination. R squared adjusted, trash can that thing. You don't use that in this class. That's more advanced statistics. You don't use that. So bottom line, you pretty much only use A, and you only use that part. You might be asked to use that part, but forget that top row and forget R squared adjusted. What are the probability symbols? So there's different symbols. If you have a U, something that looks like a U, that means or, and you would add the things to find the probability. I'll get more depth though about how occasionally you might have to do something else too. If it's an upside down U, that means and you would multiply those. And then if you have that line, that just means given. That you don't have to do that often. There is a formula in there, but you would do the probability A of B divided by B. You don't really have to do that often, but you might. So I'm not going to say you'll never see that, but so remember how I said for or you might have to do something else. If you look at the formula, you might be like, hey, I thought you said you just had to add the probabilities. Why does it say minus PA times B? Oh, they have that on there, but you don't really have to do that hardly ever. Only if they both could occur at one time. And the reason why that's on there is so that you don't count the probability of that twice. So in most cases, forget that part that has the minus. Only add them. But if you're like, wait, those two things could happen at once. For example, windy and raining. Oh, those things could happen at once. So you would subtract the probability of them both happening at the same time so you don't count it twice. That's the reason why that's on. How do you know if you should use mean or median for SOX? Remember how C in SOX means center. I said I was going to talk about that. I wasn't kidding. Mean, you would use the mean if there's no skew. So if you're like, oh, that just looks like a completely normal thing. Not going to happen that often. Usually use median. So you would say that. For center, we will use median because it is not, there is skew in the distribution. And once again, you don't have to calculate median by hand. You can just use one var stats. What's the difference between a binomial and geometric distribution? Personally, this is the thing that's the most difficult for me in this course, but it's not really that hard when you get down to the basics. So these aren't the only two. There's still a normal distribution. Normal is the bell curve, normal. But there are two other kinds, binomial and geometric. You don't really have to know so much about that for this course. You just need to know that binomial is going to say a fixed number of trials. So after 25 times of this. Geometric is just until success. We're going to do this until he shoots a basketball. or something like that. What's the difference between PDF and CDF? If you look at second vars in the calculator, there are lots of different CDFs and PDFs. And there's normal, binom, and geomet. And depending on what distribution you're looking at in the question, you would use any of those. So I already explained what's the difference between normal, binomial, and geometric. So now I just need to say what's the difference between PDF and CDF. PDF is just if you're looking that something is equal to it. So if the question says something about probability that something's equal to it, then you would use PDF. Otherwise, use CDF, but if it's less than CDF. But if you're like, wait, greater than, then do 1 minus CDF. You don't have to do 1 minus PDF. That's not really something you usually have to do. What do you have to say for random sampling? This is another one of those dumb things that they'll take off points for if you don't say all of these things. If you say something that's saying what process could you use for random sampling or something like that, then you're going to want to say names. You're going to want to say, well, actually, this isn't the only way, but this is the easiest way, I think, to say it. I would say, put names in a hat. No repeats. Identical slips of paper, mixed well. If you miss any of those things, then they'll be like, don't get the point, because that's just how dumb it is. What's the difference between one or two-tailed data? If you have some kind of alternative hypothesis that has just that, a less than or greater than sign is one-tailed. If it says they are not equal, then that would mean two-tailed. That's not usually what it's like. It's usually one-tailed. But if you had to find the p-value of only one side of it, you would just divide it by 2 because it's equal on both sides. So what if you have to find n? Sometimes they'll say solve for n. That's kind of a common thing. I just rearranged the formula that they have on the formula sheet to find n. You would want to do I don't need to say it, but you see that there. That's just rearranged to the formula they have. You don't, technically that flashcard, you don't need to do that. You can memorize this formula if you want so that you don't have to do all the algebra to solve for n. If they ask you to do that, which they probably will on one multiple choice question. All right, now we're going to talk about conditions. Of course, one of the FRQs are always on, they'll always tell you to do a hypothesis test. Do you have evidence of something? That means do a hypothesis test. It doesn't always say do a hypothesis test. If it just says evidence, something about finding evidence, then that means that's what you have to do. There are 4 kinds that you might have to do. Well, really, there's more than that because there could be 1 or 2 proportion or 1 or 2 mean. But there's pretty much 4 different kinds that have 4 different conditions that you would have to do. First, if it's proportion, it doesn't matter if it's 1 or 2, you still have to do all these. Random, basically you say, we are told that the subjects were randomly selected. If it doesn't say that, you say, we proceed with caution. For normal, you just do n times p must be greater than or equal to 10, and times 1 minus p greater than or equal to 10. You have to do that for both samples if it was a 2 proportion, so n1 and n2. Independent, you just have to say that 10 times the sample size has to be less than the total population. That's the same thing as the 10% rule. And once again, do n1 and n2 if there's 2 proportions. Alright, now for if it was a mean hypothesis test, it's pretty much the same thing. Actually, it's the exact same thing except for the normal condition. The sample size just has to be greater than 30. That's from the central limit theorem. You don't have to say that, but that's what it is. But if it's not, you need to graph a box plot, and I'll tell you how to do that in a minute. And you would just have to see if the box plot looks like it's normal. Here's a little thing about these conditions. I kind of feel bad saying this because they don't want you to do that. But every time the conditions are going to be met. As far as I know, there's never been a time when the conditions were not met. So if you're like, oh, that's going to take so long to graph that box plot, you can just draw a box plot and say, we see that the box plot is normal, so we continue to save time. That's just what I would do. If you want to actually do it, then you can, just to be sure. But I have to say that I am 99% confident that the conditions will always be met. Alright, here's the stupidest one. What are the conditions for the beta hypothesis test? Hey, what's that? Oh, remember, that's if you have to do that stupid linear regression hypothesis test. Usually you don't have to do that, but if you did, it's very dumb. And here's what conditions you would have to do. Random, that's the same thing as the other ones. Normal, though, it's not the same. You have to say, for every value of x, y varies normally. You have to do a histogram and see if it's unimodal and symmetric for that. Once again, if you were like, I know these conditions are going to be met, then just say, draw a histogram that is unimodal and would fit the data and say that it's normal. Independent, luckily that one you don't really have to do anything. If it's random, then it's independent, but you would want to say for every value of x, y is independent. Linear, for linear, you would want to do a scatter plot to see. Once again, I'll tell you how to do that in case you wanted to, but you could just say the scatter plot is linear and draw a linear scatter plot. You also have to draw, you can't just say. Equal variance, that's the last one. You want to do a residual plot and see if the dots are equal above and below. Same thing. You can just draw one if you want. Because remember, these graders are looking at 500 papers, probably, at least a day. I don't really know exactly, because I don't do that, obviously. But they're not going to be like, that residual plot, that seems like that's made up. No, they don't have time for that. They're going to just see that you did it, and they'll just do it. Alright, the last possible thing, and there's someone that predicts what FRQs there might be, and they said a couple days ago that there might be a chi-square, or chi-square, however you say it, hypothesis test tomorrow. Then you might want to pay attention to this. What are the conditions for this one? Oh, luckily only 2. Random, oh, it's the same as always. Expected counts, though, what's that? Oh, of course they want you to do a formula, but there's an easier way. Only do expected counts by formula if you have to, and that would be in a multiple choice. For FRQs, calculator for everything, you do want to show your work. You're going to want to put, so remember there's 3 kinds, and I'll explain the difference between them too. But there's goodness of fit. For that one, it's kind of easy. If there's talking about a coin or something, the proportion of the coin is this, like, or something, then the expected counts, let's say you're flipping a coin, the expected counts for tails, if you're doing it 10 times, would be 5. Why? Because half the time. So that the expected counts you just have to do by just knowing for goodness of fit. But if it's independent or homogeneity, however you say that word, for some reason I can't say that well. I'll just say homoj. You put your data in matrix 2. Make sure the matrix is on the right thing, something times something. There's a matrix button on the calculator. That's how you get to that. Put the data in A for whatever table, because remember, one way that you can know if it's independent or homoj is if it's in a table. And then look in B, and it will already be in there, the expected counts. And they must be all 5. Once again, they probably are going to be, because they don't. Why the heck would they make something that the conditions don't work? Then you couldn't even do calculations. So remember they have to be 5. Alright, here's the things that I said if you did want to graph them. If you want to graph a box plot, only reason I can think of that you would have to do that is if you were doing the normal condition for a mean hypothesis test and the population was not at least 30. You just go to stat plot. For almost all of these, just go to stat plot. Make sure your data is in L1, and then click on that thing, and then, yeah. Make sure that your freq, like FREQ on there is 1, or Y list 1. X is what should be L1. What if you want to do a histogram? If you need to do the normal condition for the linear regression hypothesis test, stat plot and click on that. What if you want to do a scatter plot? Then same thing, but just click on the scatter plot button. Now residual plot, that one's a little bit more complicated, okay? But not that much. Only difference is that you need to make sure that you set the Y list as resid. So you will click the list button and scroll down to resid. Now make sure that if you have to graph another thing, that it's not still on resid, or that will mess up the graph. All right, what is the conclusion for any hypothesis test? You have to say it like this. We reject or fail to reject the null hypothesis that, and then say whatever it was, because the p-value is less or greater than the level of significance. Don't draw that symbol, say level of significance. I was just doing that for space. There is or isn't sufficient evidence to suggest that, and then say what the alternative hypothesis is. Remember, if it's less than the level of significance, which is almost always 0.05, if the p-value is less than that, reject. If it's greater than that, fail to reject. What are the 4 steps for a hypothesis test or confidence interval? Parameter, that's just where you say, we are finding this, and then you say that HO equals that, and then HO is P equals that, or not just P, obviously, like P or mu or whatever. And then the alternative hypothesis. Then the conditions, now I already said what the conditions are, but you need to say what test you're doing, and don't do calc speak. So don't say, we are doing a t-int. Say t-interval. For whatever reason, that's just what you have to do. Calculations, that's the easy part. You just type it in the calculator, just do the test, and then click on whatever test you're doing, type in the values, bam, tells you what the p-value is. Conclusion, I already said what you do for that. What is a paired t-test or interval? Now, remember I was like, you might be like, hey, I thought you said the only 4 kinds of proportion means linear regression and chi-square. Well, this is kind of a type of mean one. It's not that common, but if you happen to have data in a table, then that's a sign that you might have to do this. It's if you're trying to find the mean difference between 2 things. So, is there a difference? And I forgot to say that the null and alternative hypothesis are a little bit different. They're going to have, I'm not going to say it in this video, but they have like D in them. But you just want to put the differences in L1. Don't do something in L1 and L2. Just look at whatever table they have and subtract all the values that they have in their 2 columns. And then you still do a t-test. You're going to still want to say, we are conducting a paired t-test, but there's no option for that in the calculator. So just do t-test. What are the 3 kinds of chi-square tests? Goodness of fit is the first one. It's if there's something basically where you're like, the proportion equals this, and you're basically saying in the alternative hypothesis, one of these is not equal to that. So an example would be, oh, we're flipping a coin, and we see that it was heads this proportion of the time, and tails this proportion of the time, and we're trying to see, oh, was that actually what it was, or whatever. And then independent and homoj, they are if you are in a 2-way table. That's how you know. But what's the difference between them? Independent is just basically you're saying, are these 2 things independent? So let's say you have color of M&Ms and flavor. Are those things independent or something? And you would use the 2-way table. And then homoj is the rarest kind that you would have to do, but it's like saying 2 proportions are equal and you're trying to see if one was wrong. Once again, that seems similar to goodness of fit, but it's going to be 2 different proportions are equal to each other, and it's from a 2-way table. Goodness of fit is not a table, only independent homoj. What does it mean if a confidence interval includes 0? If it includes 0, that would mean that the first thing was negative and the second was positive. And that means you have no evidence of whatever you're trying to do. For a paired t interval, you would say there's no significant difference. How do you interpret a slope? Here's another one of those things that they could take off points for, just for this one word, predict. Now, this is obviously not the same as what you would do in your algebra class. We're talking about for the linear, the regression line. So what we're predicting. So the slope, you would say for one increase in x, we predict y to do this. You have to say predict. If you don't, no point. For a, or the y-intercept, you would say when x equals 0, we predict y to be a. And don't say a, obviously say what value a is. How do you calculate degrees of freedom from a two-way table? You might be asked to do that. It's not that hard, really. You just do the number of rows minus 1 times the number of columns minus 1. All right. What are the layouts for binom, PDF, CDF, or geometric PDF or CDF? So if you had to do a calculation, obviously they have their formulas that are on the formula sheet. But like I said, usually unless asked, you want to do it by calculator. And whenever you click on those, type in the values in this order, N, P, X. Most cases. Occasionally you have to do X minus 1. I'm not going to get into specifics right now. Once again, if you have any questions, please comment. What must you say in the conditions for confidence interval? You need to say what percent you're using. So for saying, if the question says conduct a 90%, 98% confidence interval, whatever, you say we're doing it at 98%. What is the formula for confidence interval? This is the last one that I'm doing. It's just a test statistic. Remember, I already said how to find that. Plus or minus the T star or Z star, whatever one, remember, depending on what situation, times the standard error, which you just get from the formula sheet. So, that's the end of this video. I know it was long, but I hope that this covers almost all the things that you could get mixed up with. Of course, this is not the whole course, but actually, to be fair, it is a lot of it. But also, some of it may have not made sense if you didn't understand some things. But this is most of the course. This actually should cover almost all of what you would ever have to do on an FRQ, aside from number 6, which is, remember, going to be something that you've never seen. And they don't necessarily expect you to get it right. So for number 6, remember, there's going to be A, B, C, D. I mean, there could be more than that, but usually A, B, C, D. A and B are going to be something you know how to do. C and D are like, what the heck? And you might get it right, but you might not. But anyways, good luck to you on your AP Statistics exam. And I do realize the thing about this channel that I don't know if many people have heard me say before, but I'm not a certified teacher. So what that means is that I might not get every single thing right. I share what knowledge I have, but that doesn't mean that I know everything or that I have every single thing right. So I will not get upset if you comment a correction. So if you're like, you said this, that's not true, or something like that. I don't care if you do that. That's actually good, because I don't want to be telling people the wrong things. But also, please just don't get mad or something, because I have had some people on a video I made over a year ago for AP Physics, they were telling me that I should delete the video or something, and I was like, well, I realized that I had like a couple mistakes on there that are minor, that don't even really apply to this class, but I'm not going to delete the video because I know that it's helped some people. Like, you don't have to get everything perfect anyways to pass the exam. I know that for a fact because I passed my AP exams and I took them. And so anyways, I really hope that this helped, and remember to post any comments about something I might have done wrong or a question you have, and that'll be it. Thanks for watching.